Right, so we're discussing gas hazards as our topic. Um, this covers not just gas fitting, but it's also plumbing and drain laying. So it's across the board. So it's a pretty general slideshow. We are going to do a bit of a run through on basic gas composition because we can. So let's see how we go. What is gas fitting? Oh, here comes Ron. Sorry. So gas fitting, defined under the PGDB Act, is basically any work carried out on a gas installation that's not designed for owner to operate his or herself. It's classed as gas fitting. So for example, fitting a gas control knob or a burner cap's not classified as gas fitting. You're just putting a knob on. But if you're replacing igniter, a regulator, or a thermocouple, functional components of that gas piece of equipment, that is gas fitting, and they are not allowed to do it. So that work must be carried out by a qualified authorised person. That can include someone who's in training under supervision, such as yourselves, apprentices. That must be while they're meeting the terms and conditions of their license. So for the first year, they should be in direct supervision of their certifier or a nominated person. What is a gas? All substances are made up of molecules. In solids, such as metal and wood, the molecules are packed tightly together and do not move around readily. Basically, they're pretty much in one position. In liquids, molecules have more room between them, so they move and take the shape of any container to which they're put. So they'll spread out, filling that shape, as we know, glass of water, for example. In gas, the molecules have a lot more room to move around freely and quickly. These molecules are consistently bumping to each other in their containment. This bumping and bouncing creates the pressure we get inside our gas pipes. Because they move in all directions, they create equal pressure on any container in which they are enclosed. That means that gas containers or gas pipework, anything to do with controlling gas flow, must be gas tight. So if we have a leak, it's going to find a way to escape. It won't all escape at once, but it will continue to escape until it equalizes itself with atmospheric pressure. So it'll basically empty itself from where it is to wherever it can get to, if it has the chance. Sure, if we're going to do those YouTube clips. Going to do the YouTube clips, Ron? Ron is muted, fortunately.
Oh.
This is the full fat version of the PowerPoint. So we did have a trimmed down version for online, but I couldn't quite locate that. So here we go. Natural gas. Natural gas is a common gas. It's also another predominantly methane. So basically natural gas is a trade name, if you like, or a name that's used, common name. We think of pipes, natural gas coming through the pipework to people's houses as natural gas, but it's pretty much predominantly methane. A few trace elements of other gases in there, but it's been refined and it's pretty much just methane. So methane is CH4, one carbon molecule with 4 hydrogen molecules. Now there's not just one molecule, there's thousands or millions of molecules traveling in a pipeline as it's transported from where it is to our gas equipment for use. Now, methane can also be produced naturally through decomposing organic matter. So it can be found in the ground, in drainage excavations, for example, naturally occurring. Naturally, it's actually odorless and colourless, being a gas, you can't see it. But natural gas, or methane, that has been refined and piped around the country to used for a heating source. They add an odorizer to it called ethyl mercaptan, and that gives it that what you would term a gaseous smell. So it's faintly sulphurish. Some people say it smells like rotten eggs. Sorry, just having a quick check on the chat there. Where does natural gas come from? So basically, it is the decomposition of natural things. So trees, forests, organic matter that are millions of years old. Sometimes it's oceans that have been the ocean floor and things like that. So it's been trapped inside various different layers of rock under the earth, where an opening, almost like a cave, is formed. And because some rock is impenetrable and other rock is porous, it's created a fissure where oil and gas can build up. It may contain water, oil, sometimes it's predominantly just gas, might be mostly carbon dioxide or something down there. So all different gas wells or oil wells have different mixtures and different makeups. But the ones that are feasible are ones that have a high enough concentration of things that they want for refining. So either oil, so they can turn into plastics and petrol, or gas. A lot of the oil wells originally, when they first started doing it, they just flared off and burnt off all the gas. They didn't really have a use for it at the time. But as technology has improved, the gas has also become a very valuable resource, and that's been piped off to be utilised. And it provides a big energy source for the majority of the North Island through a piped network. Why do we use natural gas? When it's set up correctly and installed competently with appropriate gas burning equipment, it's a very efficient, clean burning fuel. So it's an excellent source of heat. It's also quite energy dense, so it allows you to create quite a large amount of energy for hotels, heating large amounts of water for hundreds of people in short time frames. So gas is very, very efficient. We'll try a YouTube clip, see if that works for us.
Natural gas. Natural gas is primarily methane or CH4
Is that working?
with smaller quantities of other hydrocarbons. It was formed millions of years ago when dead organisms sunk to the bottom of the ocean and were buried under deposits of sedimentary rock. Subject to intense heat and pressure, these organisms underwent a transformation in which they were converted to gas over millions of years. Natural gas is found in underground rocks called reservoirs. The rocks have tiny spaces called pores that allow them to hold water, natural gas, and sometimes oil. The natural gas is trapped underground by impermeable rock called a cap rock and stays there until it is extracted. Natural gas can be categorized as dry or wet. Dry gas is essentially gas that contains mostly methane. Wet gas, on the other hand, contains compounds such as ethane and butane, in addition to methane. These natural gas liquids, or NGLs for short, can be separated and sold individually for various uses, such as in refrigerants and to produce products like plastics. Conventional natural gas can be extracted through drilling wells. Unconventional forms of natural gas, like shale gas, tight gas, sour gas, and coal bed methane, have specific extraction techniques. Natural gas can also be found in reservoirs with oil and is sometimes extracted alongside oil. This type of natural gas is called associated gas. In the past, associated gas was commonly flared or burned as a waste product, but in most places today it is captured and used. Once extracted, natural gas is sent through small pipelines called gathering lines to processing plants, which separate the various hydrocarbons and fluids from the pure natural gas to produce what is known as pipeline quality dry natural gas before it can be transported. Processing involves four main steps to remove the various impurities: oil and condensate removal, water removal, separation of natural gas liquids, sulfur and carbon dioxide removal. Gas is then transported through pipelines called feeders to distribution centers, or is stored in underground reservoirs for later use. In some cases, gas is liquefied for shipping in large tankers across oceans. This type of gas is called liquefied natural gas, or LNG. Natural gas is mostly used for domestic or industrial heating and to generate electricity. It can also be compressed and used to fuel vehicles and as a feedstock for fertilizers, hydrogen fuel cells, and other chemical processes. Natural gas development, especially in the United States, has increased as a result of technological advances in horizontal drilling and hydraulic fracturing. When natural gas is burned, there are fewer greenhouse gas emissions and air pollutants when compared to other fossil fuels. In fact, when used to produce electricity, natural gas emits approximately half the carbon emissions of coal. Despite fewer emissions, natural gas is still a source of CO2. In addition, methane is a potent greenhouse gas itself, having nearly 24 times the impact of CO2. During the extraction and transportation process, natural gas can escape into the atmosphere and contribute to climate change. Natural gas leaks are also dangerous to nearby communities because it is a colorless, odorless, highly toxic, and highly explosive gas. That's natural gas.
Right, so that was a reasonably informative overview of natural gas and where it comes from. Obviously, there's a little bit of discussion. There's been quite a lot of discussion in the media about natural gas kind of being phased out and stuff like that, but there's no real viable alternative at the moment. So it's not likely to happen in the short term, and there is studies going on around the world. England, some areas converting to hydrogen, so there's potential alternative gas sources or that could replace natural gas in the network as it starts to get phased out, either from environmental reasons or lack of supply, because there's only so much in the ground. Going on to the other type of commonly used gas, LPG. Or universal LPG. LPG is actually made up of two gases, propane and butane. The main difference between LPG and natural gas is that propane and butane are both heavier than air, and natural gas, or methane, is lighter than air. So with that being heavier than air, it brings some safety aspects to it, and that if it does leak, it's more likely to stay in the location where it's leaked. So a lot of requirements around LPG bottle installation are due to its fact that it's heavier than air. So if it did leak out, you wouldn't want it going underneath your house, where if it ignited, it could blow it up or cause a major fire. Whereas if it was natural gas, it's likely just to dissipate off into the atmosphere. Why is it called liquefied petroleum gas? Because in its general stored state, it's actually compressed so much that it's turned into a liquid. So in an LPG system, fed by LPG bottles, usually have two. You've got a twin bottle pack, would be the normal, two 45 kg bottles that draw off one bottle at once. So when you turn on your gas heater or your gas oven or whatever you happen to have, that reduces the pressure in the system. Also reduces the pressure in the bottle, and the liquid, when the pressure is reduced, vaporizes and turns into more gas, replacing it, giving you a consistent supply. It does that by absorbing heat energy from the steel of the bottle itself, which ultimately absorbs it from the air surrounding it. So there's limitations to that. If it's particularly cold and the draw-off is particularly high, you can have bottles icing up, where moisture that's condensing on the bottle turns to ice, effectively insulating it from absorbing more heat. So that's why correctly sizing the amount of storage for the expected use is quite important, which is basically all part of having a compliant design. Again, another gas, LPG is also colourless and odourless, but again, in manufacturing, an odorizer is added, so very similar to natural gas. Neither of LPG or natural gas are toxic, but they can suffocate you if it's displaced the air. LPG would be more likely to, as it's heavier than air. So if you're in a low-lying area and there was a gas leak, it would push that air out. Obviously, both gases are flammable, and depending on the mixture of air or oxygen in the air that are mixed with it, it may be an explosive mixture, and you don't know. You can get a gas detector that will tell you there's gas there, but you're unaware of the quantity in the mixing. You can't see it, you don't know. So you have to presume, if you come across a gas leak, that it is potentially explosive, and take appropriate action to minimize the risk of harm to yourself. Basically, get out the way, find out where it comes from, turn it off, and ensure there's no ignition sources on the way. What's LPG used for? A whole heap of things. Also used in vehicles. CNG, compressed natural gas, in the past was used in vehicles. That's sort of been phased out. So it's a whole large range of applications for gas. Oh, now we're going to get technical. Why are butane and propane used in combination? Butane and propane have difficult chemical compounds, but they are similar. Their properties are similar. So they've just, one's got a slightly longer chain, effectively. So they're still hydrocarbons made up of hydrogen and carbon molecules, just a different amount of each one. The main difference, practical difference that makes, is that butane boils at a different temperature than propane. So propane will actually boil at -42 degrees centigrade, whereas butane will only turn to a gas at around -1 degree or 0.6 degree centigrade. That can mean in very cold climates that when you're using your gas for heating, for example, and it's sub-zero outside, you could actually run out of gas and then still shake the bottle and find there's gas in the bottle. That's liquid butane that is not coming out because it's too cold for it to absorb enough heat energy to vaporize and become a gas. In particularly cold climates, they often use a propane-only mix. Advantages of LPG. If it's set up correctly, it's clean burning, similar to natural gas. They can be stored and easily transported, so you can get LPG cylinders in varying sizes, obviously used for barbecues and camping, cooking, and all sorts of things. So it's quite a portable option, which gives you long, reasonably long duration cooking. There's quite a lot of energy stored in a small volume of LPG. We might skip through a little bit here. just because I want to get to the more general gas hazards parts of it. Liam, do you have a question? Saw your hand up there. Maybe not. Just lower your hand, Liam. Thank you. Did it for you. Right, sorry about that. Just trying to keep on top of everything that's happening. Combustion. At its most simple level, gas fitting involves mixing fuel gas with air and then igniting the mixture. This results in the air gas mixture burning, which produces heat. There's also other byproducts formed from that combustion. So when we talk about combustion, we can get complete combustion, where all the inputs are consumed and mix with oxygen without running short of oxygen, because that's what's having the reaction with. Let's try a little activity here. So in the chat, someone's asked me to write this down. You can take notes if you wish. We would encourage that if you come across some good points. But we're also going to send everyone a recording as well, even if it was a bit of a disaster initially like this one. But we'll be sending you out a link to the recording so you can review it later. You've also got your study guide. They're available online on Skills Bank. So you've got that option as well. So there is plenty of info out there. Right, so here we go. I'm going to have a little question session. We did have question slides, but I'm missing them in this version of the PowerPoint. So if natural gas is CH4 and it mixes with oxygen, which is O2, what are we going to get out the other end? So go to the chat, open up the chat window. You might have more than one version of O2 to get complete combustion, I would think. But let's see what gases you can come up with as your products of complete combustion. There we go. Ron's just given me an update. There's some questions at the end, but we're going to do one now anyway. I've yet to get an answer. There we go. CO2. Thank you, Jordan and Heath. Yep, so CO2, which is someone type the long version of CO2 to make sure we're on the same page. We've got half the products of combustion. What's going to happen with the hydrogen? Yep, carbon dioxide. Thank you, Zane, and a few others. Glenn's chipping in there, H2O. Yep. That's all right. Yep, no, that's looking good. So, yep, so our products of combustion will be CO2, oops, CO2 plus H2O. So we're going to get carbon dioxide and water vapor from complete combustion. Does anyone know what products we might produce if we have incomplete combustion? If there's a shortage of oxygen, what undesirable gas and other byproducts are going to be produced as well? You're still going to get plenty of carbon dioxide and water vapor, because if you didn't have enough oxygen, combustion would stop and just go out. The flame would be extinguished. But in smaller quantities, what are you going to get that's concerning? Yep, Paul's chipped in there, carbon monoxide, and Jordan. Yep, so carbon monoxide is a big one. It's another gas that fits in with this topic. as the critical one we need to be aware of. There's one more thing that isn't totally like a gas. Nitrogen, someone's put, yep, well, nitrogen's a gas. Nitrogen will actually go through, it'll be in the air, so the air is actually predominantly nitrogen, only about 21% oxygen. And the nitrogen should go through the combustion phase without changing. So it'll just be there at the start and be there at the end, padding out the atmosphere. So there's one more thing, which is carbon, or commonly known as soot. So if you see black stains around a heater or a gas fire or something, that's a big indicator that you've got incomplete combustion and you've got a problem. You may also see yellowy flames instead of blue flames, floppy flames. So there's a whole heap of visual indicators that tell you that you've got a combustion problem. Usually the main cause is a lack of air getting into the appliance. So even if you're just doing plumbing drain laying, still doesn't hurt to be aware of these things. Now, quite a few people have died that had no knowledge when they've gone camping, something like that. So they've gone camping, had their little barbecue or camp stove. It's been freezing cold in the middle of the winter, and they're in a little hut, and they turn that on and cook their sausages, leave it on. It's supposed to be used outside, and they keep it going because it's so cold, and they end up poisoning themselves from carbon monoxide poisoning because it uses all the air up in the room. It's not being replaced, and then people get carbon monoxide poisoning and die. So there we go. There's a visual representation of what we just talked about. Water is a vapor, so steam, and carbon dioxide. So carbon dioxide's relatively harmless. We breathe in oxygen and breathe it out ourselves all the time, so there's plenty of it around. But it is considered to be a greenhouse gas, one they're concerned about. And obviously, if it's displaced all the oxygen, then we're going to start getting carbon monoxide and or just a lack of oxygen in general, and it can become a problem. Now we're going to go into a bit of depth in carbon monoxide because that's one of the sort of bigger topic areas in the assessment. So you have a few questions on there. Carbon monoxide is slightly heavier than air, so it's going to hang around, which is another reason it's dangerous. Another danger is that as your bloodstream absorbs it, it hangs around in your bloodstream for quite a long time, and it actually blocks your blood's hemoglobin's ability to absorb oxygen. So ultimately you kind of get starved of oxygen, but in your blood. So it's a pretty serious thing. So even if you got out of that environment, you might still go downhill. So if you think someone has been poisoned by carbon monoxide, it's critical to get them medical help. So they really need an ambulance and to go to hospital. Products of incomplete combustion. So you still get your carbon dioxide and water vapor. We've got those images there. And you're also to get carbon monoxide, which is carbon dioxide with one oxygen molecule missing. That's because there was a lack of oxygen when combustion occurred. So just looking at the flame, if you're doing commissioning, which you're probably not at this stage, but just looking at it visually, that's only one indication. That won't necessarily tell you how the thing is performing. So carbon monoxide detectors, testing the flue system's operation are other critical checks that must be done as well. The biggest risk, well, one of the big factors with gases is it makes them so dangerous is we can't see them. So we can't visually see the hazard. If we're working on a site and there's a hole and there's a digger, there's a power line, all of those things are comparatively more obvious. So we can look at them, say, look, there's a digger, that's dangerous. I need to keep well clear of that. It might knock me over. With a gas, you're not going to get the same warnings. So we have to be even more vigilant and use our nose as one way that we can identify the risk. The other one is using electronic detectors. If you're working in a confined space, for example, an inspection chamber or a manhole if you prefer, where there's potential for gases to build up, then you should be testing before you go in. You need need to monitor it while you're in there, and you need an exit plan to get out safely if things change and you get caught out. Danger of flammability and combustibility. Flammable things can be burned and combustible things are easy to ignite. A flame or a spark can ignite any flammable gases in the air, causing a fire or explosion. That's if the air-gas ratio is in the flammability range. For example, natural gas is approximately 5 to 15% gas in air, and LPG is about 2 to 10% gas in air. Acetylene is something like, it's about 2 to 80%. It's got a really wide range, might even be less than 2. So different gases have different flammability ranges, making them, I guess, more or less explosive than others. But we have to presume, if we think there is a gas leak, that it is potentially within its flammability range, because we won't know. So we need to treat it as if it is. Just another term, concentration of gases is the amount of gas type in a given volume of air. If there's a lot of gas in a confined area, it's said to have a high concentration, which is dangerous. For example, a high concentration of carbon dioxide can replace the air in a confined space, the point where there's not enough oxygen to allow the person to breathe. So we need at least about 19% oxygen. Normally there's about 21% in normal atmospheric air, but in a confined space or a restricted space, that can change, particularly if you're doing work that's consuming oxygen, or if it's just not ventilated well. So it is important that you may have to pre-ventilate a space, even a trench, to make it a safe work area if there are low-lying gases that have displaced the normal atmosphere in that location, and monitor it to make sure you remain safe. Poisonous gases or toxicity. So some gases are particularly toxic. Carbon monoxide is one example. It's actually measured in parts per million. So amounts above about 30 parts per million are considered to be dangerous. If you're getting up to 50 parts per million, you want to take action to get out of there rapidly. So a very small amount of carbon monoxide is potentially deadly. So you might still have loads of oxygen, but because you're breathing in carbon monoxide, it's going to potentially kill you without action being taken. And you may not even know that it's happening. That's the scariest thing. So one potential reason why carbon monoxide might be produced is engines running in a confined space. There was quite a tragic death in Christchurch a couple of years ago now, where a family had got on holiday and they had their friend staying at their house, house sitting for them. Now the friend, being a good friend, decided to idle their car, the people that lived there's car, in their garage, charge the battery up. That was all well and good, but unfortunately the garage was attached to the house, and the wind blew the exhaust fumes into the house and actually killed the whole family. They all died of carbon monoxide poisoning. They didn't even know it was happening. So it is really dangerous. If they knew more about carbon monoxide, they wouldn't have done that in the first place. They would have taken it for a drive around the block instead. Densities. Gases density is compared to air, because air is what's around us all the time. So if it's got a number less than 1, it's lighter than air. If it's got a number above 1, it's heavier than air, air being 1. So as we stated already, natural gas is lighter than air, so it will rise up and disperse. LPG is heavier, it will fall down. And in your study guide, there is a table outlining the main gases that are covered in the assessment and which ones are heavier than air, flammability limits, stuff like that. So you will need to go back to your study guide for a bit of additional information, detailed information when you do your assessment. The other thing to watch out for in your assessment is there's a few multi-choice questions, and some of those have other gases that we haven't talked about. So if it's a gas we haven't discussed or it's not covered in your study guide, it's likely a wrong answer. So there's a tip from me. So identifying the gas, smell is probably our number one go-to. So fuel gases that are reticulated have no natural smell, but in manufacturing, a smell is added. So ethyl mercaptan's added, it creates that common gas smell. Naturally produced methane and carbon monoxide have no smell, so that makes them particularly dangerous. Hydrogen sulfide smells like rotten eggs, so that can be identified. Problem with all of these gases and the smells is that after a period of exposure, you tend to not notice it anymore. So it's only really that initial thing, and it can be quite faint, where you can smell the gas. If you don't take action or realize that that actually is gas, you just kind of acclimatize to it, and you may be in a dangerous situation and no longer realize it. So it's only sometimes when someone comes in who hasn't been in that environment that they can pick up on the actual gas leak and let you know. So if you do smell something you think is gas in a potentially dangerous situation, I suggest you take action and treat it as if it is gas. Sewer gas is a whole mixture of various gases and can have an unpleasant smell. So that may include methane and hydrogen sulfide, ammonia, carbon dioxide, sulfur dioxide, nitrogen oxide. So all of those can form due to decomposing sewage, organic matter, stuff like that. Can be flammable. If we get to the end in a reasonable time, I actually had a PowerPoint going earlier with a bunch of exploding manhole covers and the streets blowing up. So it certainly can be pretty flammable if ignited, which is quite scary. Ground gases, which you might find if you're excavating in an area that rubbish has been dumped in, sort of thing, landfills. In Silverstream landfill, relatively close to where I live, they actually have a whole bunch of pipe work speared into the ground or put in as they're laying the tip, and that draws out gases that are forming naturally in the ground, and it feeds some big generators and pushes power back into the grid from that. So decomposing rubbish, organic matter can certainly produce enough gas to run some fairly big generators. They power about enough, equivalent of about 40 houses worth of electricity just from the rubbish tip. Ignition temperature. So it's not just a spark or an open flame that will ignite gases. Hot surfaces can ignite them as well. Some gas appliances use a hot surface igniter to ignite gas. We've got one in our workshop. But things like an exhaust pipe or something like that, a hot piece of metal, if it's been welded, may ignite gases as well. So different gases have different ignition temperatures. Ballpark in the range of about 600 degrees centigrade. But if the air gas mixture is at the flammability range, where it will ignite and explode, and it comes in contact with a hot surface, it can just spontaneously combust in an explosion. So we need to keep hot surfaces away of areas where there's a potential gas leak. Different gases burn at different temperatures. The energy required to start and sustain combustion reaction is much less than the energy released by the combustion reaction. So it requires energy to ignite a fire or burning gas. A reaction's taking place where oxygen is breaking off. Oops, I can't actually read my slide because my little window was in the way. But it kickstarts the chemical reaction where the oxygen molecules break away and create new gases like carbon dioxide and water vapor. So once a fire is underway, it doesn't require much energy to keep it going, provided it's got what it needs to sustain combustion. This is, I think, an extract from your study guide. So you can go back and have a reference at that. So I've got some common gases there: LPG, natural gas, methane, carbon monoxide, oxyacetylene, carbon dioxide, and hydrogen sulfide. They are really the main gases that we're worried about and the ones that are going to turn up in your assessment. Breaks it down, they're all invisible. All except for carbon dioxide are flammable. Concentration, I don't worry about that one too much. Toxicity, so the toxic gases are carbon monoxide and hydrogen sulfide. So that means they're poisonous. If you breathe them in, it can kill you. Relative density, LPG is heavier than air. Natural gas and methane are effectively the same thing. They're lighter than air. Carbon monoxide, oxyacetylene, and carbon dioxide are similar to air. Carbon dioxide is slightly heavier, and hydrogen sulfide are heavier. So heavier than air gases are dangerous in low-lying areas, like a drainage excavation. They're likely to build up there, potentially displacing oxygen, which can cause to asphyxiation or suffocation, because you don't have the oxygen to breathe. Also, if you had, for example, hydrogen sulfide, it's a toxic gas. So if you're breathing that instead of oxygen, it can poison you as well. Noticeable smell. So natural methane, carbon monoxide doesn't have a smell. There's a couple of others there: carbon dioxide, oxyacetylene. Presumably the acetylene part of the oxyacetylene, not the oxygen part. But most of the other ones do have a smell or an odorizer is added. Ignition temperature, it's a range of different ignition temperatures there. There is one activity that's a little tricky. It's a drag and drop activity. And where it shows the temperature scale, then you've got to drag particular gas in order of its temperature. Two of them are quite close. Just put them in the order of the temperature based off the table. Only use the gases outlined in the table. So don't use any gases that aren't listed. Otherwise, you'll get the answer wrong. And then the burning temperature. So the temperature of a flame, effectively, of that gas during combustion. So you see the burning temperature is actually really high, but the ignition temperature is relatively low in comparison. 270 degrees is not that hot. An exhaust pipe could, for example, potentially ignite that. Ignition sources. So there's a whole range of ignition sources, some more obvious than others. Obviously, an open flame is going to be an ignition source. Smoking, welding, sparks, hot surfaces, static charge. That's one that's not obvious. So plastic, nylon type clothes, taking those off. Sometimes you might see at night, you take the top off in the middle of the night because you're too hot in bed, and you see this sort of spark, static electricity. Well, that could be igniting a gas leak if that's happening. Mechanical sparks, so a tool, even a shovel hitting a rock or something, may create a very brief spark. It might be enough to ignite the perfect gas mixture. Also, electrical arcing. Excuse me. So, for example, if you're in a house and you inadvertently create a gas leak because you left the uncapped end or something and turn the gas on, you wouldn't want to turn off a light switch. Turning it off can potentially create a small arc in the switch itself, which could ignite the gas. So you're better to leave something on than flip the switch. Skip through this one. Sparks, flames, hot surfaces, glowing embers from a fire, hot surfaces, ceramic bricks, things like that. So there's various things that are out there, exhaust manifolds, lamps and torches, particularly the old school ones, not LEDs so much, but they may be ignition source. Right, eliminating source of ignition. So if you're going to do any work, if you're doing gas fitting work and you're going to cut into a pipeline, you'd want to isolate it. You'd want to make sure that there's no ignition sources anywhere near or around where you're going to do the work, and that you're not going to create any in the process of your work. You also need to make sure that other people around your vicinity are not going to create any either. And you may have to keep them away from your work area. Obviously, if you're doing drain laying or plumbing and you're digging a hole in the ground, you want to try and minimize creating sparks. Certainly if you think you've hit a gas main or you're smelling a gaseous smell, you need to treat it as if there could potentially be gas there that may be explosive, and also take care not to create ignition sources. You may need to create enough ventilation to disperse the gas that's there to make it safe to work again. So there's four main hazards relating to gas hazards to you. So they are asphyxiation, which is suffocation. So that's basically there's a lack of oxygen. So that could be heavier than air gases have displaced the oxygen, putting you at risk of suffocating. Toxicity, so poisonous gases have been released. One example was carbon monoxide. That'll definitely come up in your test. The other example was hydrogen sulfide. They're both toxic gases that can lead to poisoning and ultimately death. Flammability. So you've got gases that are explosive. It can also include things like solvent fumes and stuff like that. As plumbers, I'm sure you've aware that glue, PVC glue, is highly flammable, and so is the primer. So the fumes from that can potentially ignite and create a fire as well. It doesn't just have to be the gases we've talked about. And explosion. So if a larger volume of gas has been released, can lead to massive explosion. I look at the Christchurch house explosion there. That was from an uncapped gas pipe releasing gas out. It ignited from a switch, blew the whole house to pieces. Very lucky no one died. Other hazards that are, again, less obvious is a potential stray current running down a metal pipe. So metal pipes, conductors, they can carry electrical currents. Some older homes, probably 1950s or before, maybe even later, in some cases, the earth for the house's electricity was bonded to the water pipe, usually a galv or copper water pipe. And if there's an electrical fault within that system, it may not blow a fuse, and it may actually have a current running to earth. If you break that current by cutting the pipe or disconnecting it, you become in the circuit, and usually that's across your chest, which may stop your heart, might lock you onto the pipe as your muscles tensen up, and you might just get electrocuted until you're stuffed. There's a clip there, maybe we'll try that. Give me a break.
Okay guys, this is a classic example why we must use condensers when we cut copper. Have a look at the sparks. See that? That means if I didn't use a condenser, I could be electrocuted right now. Very important in condensers. See that? See it? See the spark? 240 volts right
there. Yeah, so that was a particularly good example of the current.
What's up, guys? And welcome back to another video.
Sorry about that. But the sparks in that example were a particularly good example of just how dangerous a live pipeline can be. And you wouldn't know that if you just think it's another pipe cutting into it. Potentially, it could be the one that kills you. So if you're working on metal pipes in a building, certainly in the ground, you should be using jumper cables to protect yourself. We'll also, provided you don't pull it off like that, potentially also, reduce will eliminate a spark from forming, potentially igniting the gas. Obviously, you'd have to reconnect it if you did let gas out and let that dissipate before you took the jumper cable off. Otherwise, you could create a spark as well. But if you just pull the union apart, it could spark and then blow up in your face. Otherwise, and electrocute you is another risk. Right, precautions. Fuel gases are flammable. If you're working on a site with fuel gas and you smell a leak, inform your supervisor, take action, don't ignore it. Keep your workplace well ventilated. If there's accumulation of flammable explosive gases, they could blow up. So we need to get rid of those. So you may need mechanical ventilation in some situations if there's not natural airflow. If you've got a known leak or a known repair you're doing, you can manage it a lot better. If it's an unknown one, like ground gas, or you're working in a sewer or something, then it is more difficult to deal with. So you need to take even more care. You can get gas detectors that you should use if you're going into dangerous places, confined spaces and the like, where you're at risk. You need to know how to use those and have a plan in place of how you're going to deal with any hazards. Also a safety plan. So if you were the person going down the hole, for example, there is a means of getting you out with not putting the next person at risk as well. So I wasn't actually prepared to do the slideshow, so I'm running the best I can here. Turning off the gas supply. Too risky to work on live gas pipes. That seems pretty obvious, but we certainly wouldn't want to do that. Gas is under pressure. It would continue to pour out if we cut into it and try to do something. So if we work on any gas pipes, we would need to isolate the supply, ensure that it's off, purge the gas out effectively in a safe way, in a well-ventilated space, before we go in and do any work. Certainly, if it was copper, for example, we wouldn't want to be rushing in there with our gas torch just after we'd cut the pipe. We would make sure that it's well ventilated before we go in and start to do anything like that. It may even require putting in a non-combustible gas through the system as well. On bigger installations above 30 litres, you might put an inert gas through the system to take the risk down even further. Gas leaks. PowerPoint keeps giving. As gas pipes can be buried in the ground, located below floors or in a wall, ceiling voids, poor maintenance can lead to build-up leaks and build-ups of gas. This can lead to an explosion. I think you have a gas leak, you should remove everyone from the area, including yourself. Switch off the gas at the main supply. Don't go into a hazardous area to do this, because you might get asphyxiated or put yourself at more risk than need be. Turn off any obvious potential ignition sources and ventilate the property. If it's particularly bad and you think that it's likely to require additional support, ring emergency services. Wouldn't do that necessarily if it's something that you've created or something that you've got under control, but if it is something that's out of your control, or particularly large area where lots of people are affected, then that would be a good thing to do. And if it's a leak on the gas supply side, you would need to contact the gas supplier, potentially energy safety as well, depending on the specifics. You should not use any electrical equipment, drills and things like that. Create sparks, potentially. The brushes create sparks. Switch off and on lights. Go into any areas where it's a confined space, a restricted space with lack of airflow. Certainly don't light any matches or naked flames. Skip that. On a gas meter, where the gas meter is next to that, the riser coming out of the ground, is an isolation valve. Now it's a quarter turn valve, which means when the handle is in line with the pipe, it's open. When it's parallel, it's off. Some people are used to a gate valve or something that just wind them round and round and round, and it just goes off and on, off and on, off and on. So don't get caught out with that. Newer ones have a lever action ball valve, so they're a bit more obvious. They only go so far, but the old ones just turn round and round. They're like a block valve with a hole in the middle of it, sort of a wedge. So they do turn off. So just be careful there. So here we go, cordon off the area, pretty much what I just said before. Keep ignition sources well clear. Call the gas supply company if it's on anywhere on the inlet side of the meter, or anywhere the meter itself or the inlet side and the riser. You would have to call them. If you're not a gas fitter, you'd need to call the gas fitter to resolve that. If required, contact emergency services and make sure the customer and obviously your employer or supervisor are informed of what's happening, and anyone else on site. Sewage gas. Probably the biggest thing is to ensure adequate ventilation and fresh airflow. Also, if you're in a confined area, you need to monitor with an appropriate gas detector set for the right gases, the space. First, to ensure it's safe to go in the first place, to monitor it while you're in there. And you also need a safety plan to deal with any incident that might occur. So obviously, if you're monitoring the gas in the area, it should beep at a safe level, allowing you to get out. For some reason, if that didn't happen or the thing went flat, you passed out prematurely, you need to have a plan in place already to get you out safely, a realistic plan that can work. So that might be having a harness on and having a tripod, and you've got a spotter that's there and they pull you out. That's a plan that could work. A plan that wouldn't work is that your mate, you're going to ring your mate on your cell phone, and he's going to drive from 20 minutes across the road to come and save you. Well, at that point, you're dead, because one, you've passed out, you didn't make the phone call. He eventually turned up at 4 o'clock wondering where the hell you were, and found your dead body. And if he's got any sense, he'll ring 111 and get emergency services there. If he's unlucky or ill-informed, he might go down the hole and die as well. That would be the worst case scenario. Certainly wouldn't want that to happen to anyone here. Fires. Obviously, we're talking about gases. So gas fires, if there's a gas fire in a reticulated or a house supply, best thing to do would be turn off the bottle or turn off the gas supply. That might help extinguish the fire. Depends how far out of control it's got. So suffocate the supply. If you stop the fuel, it's less likely to continue to burn. Obviously, if it's ignited a bunch of other combustible stuff, it may be getting out of control. You may attempt to put it out with a fire extinguisher, but you need to weigh up the risk factor. If the thing's getting out of control, half a room's on fire, you're not going to be able to put it out. All you can do is ring emergency services and get them around, and hopefully they can put it out. Although often by the time they arrive, it's more about stopping it spreading to other buildings and saving people if they're stuck inside. Carbon monoxide poisoning, we've covered this a bit. There's a few signs of carbon monoxide poisoning you need to be aware of. Headaches, nausea, feeling sick, breathlessness, collapsing, dizziness, loss of consciousness, even feeling semi-elated or happy. It can be another symptom. Looks similar to a hard night on the town, sort of recovering from excess drinking, but similar symptoms actually. So if you know people are suffering from those and they haven't been drinking, but they've been sitting in front of their dodgy looking old fire, they may well be suffering from carbon monoxide poisoning. And at the very least, it needs to be serviced. They may actually need medical treatment if it's particularly bad. Exhaust fumes are another one. You got a leaking exhaust on your car, might get back into your car and be poisoning you as you're driving along. Prolonged exposure to carbon monoxide, you will collapse, you'll become unconscious, and if you don't get out of that environment, you'll die. If you think someone has been affected by carbon monoxide, obviously you don't want to expose yourself for too long, but you want to get them out of that environment, turn off whatever it is you think may have caused it, and get them medical assistance. You also want to ventilate the area to get rid of that dangerous gas. Toxic gases. If you're going to site where there is any possibility of accidental exposure to toxic gas, then you should be shown a site evacuation plan, where the emergency phone is, where emergency services phone numbers are, job safety analysis. There may also be safety data sheets. So if you're doing something that produces dangerous fumes or a product, It will have a safety data sheet. It'll tell you what to do if you get it in your eye. It'll tell you what to do if you breathe in the fumes and what treatment to do, because it does vary. Some things they want you to spew up, some things they don't want you to spew up. Pretty much all of them, you want to go to the hospital as soon as possible and get professional medical assistance. So if you are using chemicals and things like that, you should have access to the safety data sheet for that product. If you don't, ask your boss about it. They are provided at merchants and things like that as well, so they can put them on the right track of where to get it. Precautions to take where toxic gas are present. Obviously, you don't. Ideally, you eliminate the toxic gas if it's naturally occurring. For example, hydrogen sulfide. You would want to create enough ventilation so it's diluted so much that it's not going to affect you. In extreme situations like working in a confined space, you may have to do the job with RPE, respiratory protective equipment. So an oxygen type mask setup. That's a pretty extreme scenario for most plumbing, drain laying, gas fitting work. If you think someone has been exposed to a toxic gas, someone's passed out, unknown reason, you've got to presume that there's something untoward has happened. You want to get them out of the dangerous area and get them first aid the best you can and get professional medical help. So you need to be careful about exposing yourself to the same risks and making yourself a victim as well. That's where your pre-planning comes in. So identifying what the hazards are for your particular work scenario, identifying what gases may be there potentially, measures to control those like testing to ensure a safe environment. And if it does all go wrong, having a plan of action to get out of that situation. Find spaces. You do a separate unit training on that. I'm not going to dwell on that. I'm going to jump past that. Here's a few questions. So you're doing well. It has been a bit over time, not too much, mostly due to our technical issues at the start. So let's have a go at these questions. It has been all about me so far. We're trying to make future ones a bit more interactive. So let's have a go. So we'll go first. First correct answer for this one. What are the main components of LPG? So what are the two gases that make up LPG? Please type them into the chat. Oh, geez, it's moving so quick. I'm struggling to keep up with it here. Yep, so we got about 5 correct answers there. Going to give you people the thumbs up. So propane and butane are the constituent gases or the component gases that make up what we call LPG, liquefied petroleum gas. Well done. What is the dangers? What is the dangerous gas created by incomplete combustion? Boom. Teree, you are a blimmin' quick draw on the old chat there. Well done. Well done. Carbon monoxide. Carbon monoxide is that. Oh, geez. God, get out of that. Just about gave all the answers there. That was a accident. Lucky you were looking at the chat, so that was okay. Let's get rid of the rest of them. Let's do the rest of them before I give all the answers away. Is carbon dioxide flammable? No. Yep. You're a step ahead of me. Does natural gas have a natural smell? This is almost a trick question. I won't know if it's you're answering this one or the next one. No. Yep. Correct. Can a gas fitter work on live gas pipes? No, he can't. He would need to isolate the pipe first. What tool must be used when cutting a copper pipe? This is not the tool to actually cut the pipe, it's the tool to ensure your safety. Yep, jumper leads, that's right. What's the first action if you discover someone affected by what you presume could be a toxic gas? You may not know for sure, but there's a potential for them to be affected by a toxic gas. What would you want to do? It's a bit of a tricky one because you don't want to put yourself in danger of as well. Yeah, it does depend a little bit on the situation. If possible, get them out and away from that situation. But, you know, if they're down a manhole or something and you came across them, you wouldn't actually want to go down there to do that because you're likely to end up passed out at the bottom of the manhole as well. So in that case, you'd have to call emergency services. Depending on the level of planning, you may have a plan in place already to deal with that situation. So you may retrieve them with whatever rope or harness you had. Maybe something completely different, you don't know. They may have been working there for half an hour. That may have taken that long before it's affected them. So you may be able to go in and retrieve them, but you don't necessarily know. So certainly be cautious about exposing yourself to risk. Who can perform gas testing in confined spaces? It's a trickier one. This is more just get testing for gases, whether they be flammable gases or poisonous gases. So you wouldn't necessarily have to be a certified gas fitter. It's not testing gas pipework. This is just testing an environment, I think, is the scenario. Yeah, we've got someone with a tester. I think someone who's competent to use the testing equipment that you have. So there's no good if you've never used it before. Someone gives you, here's a box, off you go. If you don't know how to do it or what it's reading or how to set it correctly, it's actually not safe. So someone who's been trained to use that gas detector correctly for the appropriate situation. So I think Hayden was pretty good there. Try and give him the thumbs up. So someone who's competent to use that tester.